Hello, this is section 8.2, page 1, and we're going to talk about perimeter in this section. So the definition of perimeter is to just add all the lengths of the sides of whatever polygon you have. There's no real formula, just add all the lengths. So here, when we look at this, we're supposed to find the perimeter. So we're going to say perimeter equals add all sides, and it doesn't matter what shape it is. Okay, so we look at this and we're going to try to add all sides. Well, we know this side is 13. We know this piece right here is 7. We have this piece is 8. Well, what we need is this piece here, and we need the whole base and this piece here. Well, notice that they told us it's a parallelogram. So we know that this piece here is also 13 because remember, in a parallelogram, opposite sides are congruent. So if we could find this side, then we would know that side, and then we'd have all 4 sides. So how can we find out this side? Well, if we knew this piece right here and this piece right here, this is a right triangle, so we could go ahead and use the Pythagorean theorem. Well, we know what this piece is. 13 minus 7 would give you 6. So this is 6 inches here. All right, so now let's use the Pythagorean theorem to find the rest. So we'll put a little side note here to find side AB, that's this piece here, the hypotenuse, use the Pythagorean theorem. So that says a squared plus b squared equals c squared. So we're going to put in, we do not have the hypotenuse, so we're going to put in 6 and 8 for a and b. So 6 squared plus 8 squared equals c squared. 36 plus 64. We've done this so many times, we've got the hang of it. That's 100. So then we're going to go ahead and take the square root of both sides, putting in a plus and minus. But we know that we're going to reject the negative because it's the side of a triangle. So we get c equals 10. Oops, not c squared, but c. Square root of c squared is c. Okay, so c is 10, which means that AB is 10. And that's what we needed. So let's go ahead and mark that this side here is 10 inches. And then because it's a parallelogram, this side also has to be 10 inches. So when we add the sides, what are we adding? We're adding 10 plus 13 plus 10 plus 13. So 10 inches plus 13 inches plus 10 inches plus 13 inches. And what do we get? 10 plus 10 is 20. And then 26, so that gives us 46 inches. All right, so that's the perimeter. All right, so let's go down to the next problem. It also asks us to find the perimeter of the parallelogram ABCD. So I know it looks like a rectangle, but we don't know that. We know it's a parallelogram. That's all we know. We do know in a parallelogram that opposite sides are congruent. So once we find this side and this side, we have the other two. So let's take a look. They gave us information about this shape in here. Okay, so what do we know? Well, we know 5 and 4. So could we get this piece right here? That's a part of this side of the parallelogram. Sure, we could. We have a right triangle. So certainly we could get this little piece. So let's go ahead and do that and get that piece. So using Pythagorean theorem, make sure you can see that, yeah. Use Pythagorean theorem, okay? We have that a squared plus b squared equals c squared. So this is across from the right angle, so it has to be c. So put that in, 5 squared. We'll put that 4 in for a, and we'll figure it out. We get 16 plus b squared equals 25. Then we're going to subtract 16 from both sides. And we get that b squared equals 9. We take the square root of both sides, putting in that plus and minus, but we reject the negative and we get 3. Okay, so that's what this side is right here. Let's go ahead and label it like this. This is 3. Okay, so now let's think about what that helps us with. Well, because this is inscribed here, we know that any time we have a line through the center that is perpendicular to a chord, it bisects that chord. So that tells us that if this piece is equal to 3, that piece also has to be equal to 3. So this is also equal to 3. So that tells us this whole piece here is equal to 6. Okay, so let's write down how we know that. Since A, B, C, D, I need to say parallelogram. Since parallelogram A, B, C, D is inscribed, I'm going to write this down here. I may want that column for later. Is inscribed in a circle. A line through the center, perpendicular to a chord, bisects the chord. Okay, so that tells us that CD has to equal 3 plus 3, or 6. Okay, so we've got that information. And then we also know, because it's a parallelogram, opposite sides are congruent. So we know in a parallelogram, opposite sides are congruent. So we also know that AB equals 6. Okay, so I'm going to kind of highlight them so we can find those later. Well, I guess we can just go ahead and do this. We can now label this as also as 6. Okay, so we've got two sides. Now what we'd like to get is this side. So that brings us to this issue here, that we have a 4 here. So can we automatically say that that's a 4 here? Well, there's a little trouble in saying that. I know this looks like a rectangle, but unless you can say it positively or prove it, you can't say it. We have 2 right angles, but that doesn't do it. We would need all 4 to be right angles. So let's talk about what we do know and how we can come to that conclusion. So because we know that this ABCD is inscribed, well, first of all, let's talk about it being a parallelogram. Okay, so since ABCD is a parallelogram, we know that opposite angles are congruent. Okay? So then we also know that because it's a cyclic polygon, since ABCD is a cyclic polygon, we know that opposite angles are supplementary. Okay? So these two things together, that's a crazy looking bracket, but anyway, it's because we know opposite angles are congruent and opposite angles are supplementary. So let's kind of highlight that. Opposite angles are congruent, opposite angles are supplementary. Supplementary means they add to 180. If they have to be congruent, what do they have to be? Those angles have to be 90, don't they? So these angles, these opposite angles must measure 90 degrees. All right. Well, we're talking about like this angle and this angle. Those would have to be 90. And this angle and this angle. Those would have to be 90. So we just found that this here, angle C, must be 90 degrees. So the measure of angle C has to be 90 degrees. All right, well now if we have 3 90-degree angles, what do we have to say about this one? This is 90 degrees too. So, and measure of angle O is equal to 90 degrees. So this guy here, this little guy, is a rectangle. So let's put some letters on it so we can, let's just say X and we'll say Y. So O XCY is a rectangle. Okay, so if it's a rectangle, then this side, the sides are opposite. So now we can say that this side is 4. So we'll say this side is 4 also. Okay? Opposite sides of a rectangle are congruent. Okay? So that side is 4, and then what do we know? Because it's a cyclic, then we know that this polygon, we know that this line through the center that's perpendicular to a chord has to bisect it. So again, that means that this piece has to be 4. So now what do we have? Well, we know that this side must be 8, and this side must be 8, and we're ready to find the perimeter. Okay, so we know now that BC has to equal 4 plus 4, or BC equals 8. Okay, so if we add all sides, now let's write perimeter. Perimeter equals add all sides, or 6 plus 8 plus 6 plus 8. So that's going to be 14 and 14, which would be 28. So whatever the units are there. So I know that it looked like all those things were true, but you have to show that they are. You can't just assume they are. So we did it. Okay, one last theorem here on this page. Heron's theorem. If 3 sides of a triangle have lengths A, B, and C, then the area A of the triangle is given by, okay, so this is not a right triangle. You know, this is just any old triangle. It doesn't have to be special. So we can find the perimeter, or we can find the area if we know all the sides of the triangle, the lengths of the sides. So it gives this formula and talks about S. So let's see, what is S? S is called the semi-perimeter. You're supposed to add all the sides up and then divide it by 2, cut it in half. That's the semi-perimeter, which we know semi means half. So here's the actual formula we use. We do all of this multiplication. Remember, A, B, and C are the lengths of the sides. And then we take the square root, and that'll be the answer. So let's try it on this problem here. So we're going to go ahead, and we know that the area is equal to the square root of S times S minus A times S minus B times S minus C. Okay? So when we go to plug in, we don't know S, so we have to go off to the side and figure out S. So S is equal to 1/2 times A plus B plus C. So S is equal to 1/2. A is 10, B is 17, C is 21. Okay, so what do we get when we add those up? We get 10 and 17's 28, 29, and then 49 is what we get. No. 17, 18, 48, I meant to say. Okay, and half of 48 is 24. Okay, so when we plug in here, we're going to get S is 24, so we put 24 in. Then 24 minus A, which is 10. So I'm calling this one A, this one B, and this one C. And you can do it any way you want. And then 24 minus B, which would be 17. And then 24 minus C, which is 21. So we're going to do inside the parentheses first. So we have 24 times 24 minus 10 is 14. 24 minus 17 would be 7. And 24 minus 21 would be 3. Now we've got to multiply that all up and take the square root. So I'm going to multiply first just so you can follow along and see what's happening. So 24 times 14 times 7 times 3. So that's 7056. And now we're going to go ahead and take the square root. So second square root of 7056. And we get 84. Okay, so that's the area, and it's square whatever the units are. All right, that concludes page 1.